This is a video on name scoping and the execution stack in APL. We're going to be using APL plus Swim in these examples, but any other vendor's APL would do. In this example here, the program report, we have N1, which is a variable, N2, which is a variable, and sex, which is a variable. All of them are global variables. They can have a value outside of the program. If we look at the variables, we can see that N1, N2, and sex all have a value. If we run the program report, we can see that it runs using the global values. The values used are not confined to the program itself. In this example here, compute is a program that takes an argument, items, and returns the result, res. Those are local variables. But constant here is a global variable which is used within the program. If we look at constant, we can see that it has value 10. If we run compute with values 2, 4, and 6, we see that the sum of these numbers is 12 times the constant 10 is 120. Items does not have a value, nor does res. Those were variables used inside the program. They were local to the program. We can run this program in the debugger. Here we are in immediate execution mode, and compute 246 appears. We now enter the function, and we can see that items has a value, which is 2, 4, and 6. Constant has the value 10. And res doesn't have a value yet. If we look at its name class, it is unknown. But items is defined as a variable. If we keep going, we can now see that res has been given a value, 120, and the function is about to exit. It's on line 0. It's about to exit. And if we look at the stack on the right here, we can see that from the immediate execution mode, we called compute, which is now awaiting to exit, and it's pending. We can see the star, meaning pending. If we now look at the stack using the system command state indicator, SI, we can see that compute is waiting on line 0. It's pending with the star, same thing as we have over here. We can actually ask for the stack, the state indicator, and the name list that tells us that we have local names, res, and items. If we now resume, APL returns 120 in the session since we didn't use it. Let's try that again. This time we're going to set the res. We're going to give it a value, a global value, and we're going to run the expression again. As we can see, items still has its 2, 4, and 6 value. Constant is still there. Res doesn't have a value, even though we gave it one here. This is the global value. Right now it is hidden. The local value is hiding the global value. And at the moment, res doesn't have any value. We keep going. Now res is a result. And we'd return it in the session again. And now the global value of res is visible again. If we look at the variables, res is still there, but items is not. Items was local to compute, and it disappeared as soon as compute terminated. Let's see another example. Let's have a look at calc A. Calc A is a program that takes one argument, A1, and it uses a local variable called TMP. The way we've declared TMP to be local is by putting it in the header, using the semicolon to separate it from the arguments. As we have seen, there is no TMP in our list of variables in the workspace. Let's run it. As we enter the function, we skip to line number 2, and we can see that K2 is our global variable with the value 2, A1 is our argument of 32, and TMP doesn't have a value yet. Once we run it, we see now TMP has value 64, and it's going to be added on line number 3 to the value 10. Let's do it now. The value 64 plus 10 has been displayed in the session. We now resume, exit the program, return to the session, and TMP does not exist. It was only for the duration of the execution of the program calc A. Let's have a look now at calc B. Calc B has a left argument called Vx and the right argument called A1, just like calc A had an argument called A1. It uses a local variable called K2, which is used internally. Let's try calc B now. We enter the function, and immediately we see that A1 has the value 12, Vx is the value 3, and K2 does not have a value. It is hidden. There is a global variable called K2, but it is hidden. We are using a variable called K2 locally, and we haven't given it a value yet. Let's proceed. Vx 3 exponent 2 should be 9. And now we are going to call calc A with 12 plus 1, 13. Let's enter calc A. As we enter calc A, we can see that the stack now displays calc A has been called by calc B, which was called in the session. Same thing if we do right paren SI and L. We can see that calc A has two local names, A1 and TMP. TMP hasn't been assigned a value yet. Calc B has got three values, Vx, A1, and K2. Notice that calc A uses local variable A1 and that calc B also uses A1. But A1 in calc A shadows the value of A1 in calc B. These are two different values. A1 in calc A has the value 13, A1 in calc B has the value 12. Notice also that the value of K2 used in calc A is not the global variable in the workspace. It's the one defined in calc B. Calc B defines its value from Vx square, and it is used in calc A as such, not from the global value in the workspace. As we resume, K2, value 9 times 13 is going to be executed and calc computed to be 117. We will now add this to the global value of K1 and return the value 127. We resume calc A and exit the program, and we exit calc B and return to the session. Here's another example. Assume we have a workspace with the following names in it, N1, N3, and N5. These could be variables, functions, or whatever. These names are in use. When we call program blue, which has the names N2, N3, and N4, as a result of being either an argument or being localized, when blue is called, it effectively shadows N3. Its own N3 is making N3 in the workspace invisible. If blue subsequently calls orange, then orange N1, N3, and N4 shadow N1 from the workspace, N3 from blue, and N4 from blue. So all it sees is its own N1, of course, N2 from blue, N3 and N4 from itself, and N5 in the workspace. To resume, all the names in the header of a program are local, except for the program itself. Each time a program is called, APL stacks it up along with its local variables. If a program calls another program, that program is stacked too, and so on and so on. This concludes this short video on the APL stack and the name scoping of variables.